Good afternoon. This is Professor Arnold, and today I'm going to talk about the binomial probability distribution. In doing so, I will explain to you a couple of examples. Let's first review the binomial probability distribution. A binomial probability distribution has a fixed number of trials that are independent, trials that are each classified into two categories, commonly referred to as success and failure, and finally, trials with the property that the probability of success remains constant. In the probability binomial distribution, the notation requires several variables. One is n, which denotes the fixed number of trials, r, the specific number of successes in n trials, p, the probability of success in any one of the n trials, and q, the probability of failure, which would be the complement of p, which would be 1 minus p. So let's get to the formula. Before that, let's talk about some simple notation. All we need for a binomial probability distribution is n and p. All you need to know is how many trials and the probability of success. So the short notation for a binomial probability distribution is binom open paren n comma p. By the way, the mean of the binomial distribution is n times p. So you might want to write that down. N times p is the mu, the mean, and the standard deviation is the square root of the quantity n times p times q. Moving on. So the probability of getting exactly r successes in n trials, this is NCR, and if you recall, NCR means the number of ways you can arrange r things from n. So 5C3 would be the number of ways you can arrange 3 things from 5. And then P to the R times Q to the R. Now there's an equivalent formula, or function I should say, on the TI-84 or TI-85 or TI-83 calculator. For our purposes, we're just going to be looking at a TI-83 and the TI-84 calculator. So the function is binom PDF, and the arguments are n, comma p, comma r. Now they have to be put into the calculator in this order, otherwise it would not give you the correct result. So the other formula, or the other function on the calculator, gives us the probability of getting r or less successes in n trials. And here it is, the probability that x is less than or equal, so I want you to make note of that, probability of x less than or equal to r is binomial CDF n, comma p, comma r. So again, these have to be placed in the calculator in the correct order. So let's turn ourselves to an example. Assume that when adults with cell phones are randomly selected, 41% of them use them in meetings. If 20 adult cell phone users are randomly selected, find the probability that exactly 14 of them use their cell phones in meetings. Well, we're going to do this first manually. Manually here means that I'm going to use the formula, but of course I will use the calculator to calculate the values because they're large numbers, or sometimes even small numbers. Okay, so the probability that x is equal to 14, that's what we're trying to find, is equal to 20C14, so the number of ways we can arrange 14 things from 20. Then we'll multiply it by the probability, 14 occasions, or 0.41 raised to the 14. then multiply by 0.059, which is the q, raised to the power 20 minus 14, and that will give us this big old number here, multiplied by 1.599 to 10 to the negative 7, which was going to give me 0.00620. And if we are asked to round to 4 places of decimal, the probability that x is equal to 14 is equal to 0.0062. So I have my problem. You see I have that in blue. I have my solution again in blue, and then answer. So I have the three aspects of the problem: the solution, and the answer. Now let's do the same problem, but this time we're going to use the calculator function binomial CDF. So that is to be found on the calculator by pressing second var binomial PDF. Second var binomial PDF. Here's the function. Here's the calculator on the right. The second key is the light blue key. Right? You hit that, and then var is over here where you see the little cross on the right side, and then it comes up with a bunch of functions, and you just arrow down until you come to the one that says binomial PDF. So what we will do here is we'll plug in, we'll substitute the values 20, 0.41, 14, so that it looks like binomial PDF 20, 0.41, 14. So we put that in the calculator. We simulate that like that, and you have the N, the P, and the R is the 20, the 0.41, and the 14 that we put in the calculator, and then hit enter, and you see up there it says 0.00620, just like we got before. So that becomes my answer. So I say answer, probability that x is equal to 14 is equal to 0.0062. So let's do another problem. Assume that when adults with cell phones are randomly selected, same problem before, so far at least, 41% of them use them in meetings. If 30, that's different from before, was 20. If 30 adult cell phone users are randomly selected, find the probability that at least 10 of them use their cell phones in meetings. So this is very different. In the one before, it says the probability that exactly, I think it was 14, use their cell phones in meetings. This one says the probability that at least 10 of them use their cell phones in meetings. In most probability classes, you will be asked this question, either when we do binomials or whether you do Poisson. Some point in time, we're going to ask you a question about finding the probability of at least something. Why that is because it tells the instructor whether you understand the probability terminology and the formulas that are involved. So let's continue. So we're going to use the calculator function, but please pay attention. This is not binomial PDF. This is binomial CDF, right? Cumulative. So here we go. Probability of at least 10 mathematically means x is greater than or equal to 10. At least 10 includes 10. So that's why for x greater than or equal to, we have to have greater than or equal to in order to include the 10. So the thing is, we don't have a function for x greater than or equal to 10. We have for less than or equal to 10, or less than or equal to 9, or anything like that. So we have to use our knowledge about probabilities. And in this case, we use the complement rule. And the complement rule says that the probability of x greater than or equal to 10 is 1 minus the probability of x less than or equal to 9. Strictly speaking, the opposite of greater than or equal to 10 is less than 10. However, these are finite variables, so the probability of x greater than or equal to 10 is 1 minus the probability of x less than or equal to 9. So let's just go ahead and put those into the calculator. So we can put the whole thing into the calculator. So I'm bring up the calculator now so you can see here. I put it in there. You see I have the 1 minus on the right, look on the right, 1 minus binomial CDF, and now I have to put in my values. 30, right? I put in 0.41, and it's not 10, it's 9 because I made an adjustment so that I could use the binomial CDF function on the calculator. So my answer is probability that x is less than or equal to 10, greater than or equal to 10 is 0.8510, 4 decimal places. So ladies and gentlemen, that's the end of this presentation. I hope you understood it. If not, you can play it again, pause it, make notes as you go along, keep playing it until you understand. Thanks for watching, and I see you again in another video.